Okay, this is lecture number 8. We'll continue the problems. Convolute x1 of t and x2 of t shown in the figures. Shown in the figures. This is x1 of t. It's like a staircase waveform. Starts at 0, ends at 2. This is 1, amplitude 1 and 2. This is x1 of t. x2 of t is a rectangular pulse of unit amplitude, starts at 0, ends at 1. Y-axis is x2 of t. In this problem, figures have been given. Width of this figure is 1 second. Width of this figure is 2 seconds. Therefore, y of t, which is x1 of t convoluted with x2 of t, should have a width equal to 3 seconds. This is 1. Now I am going to say, let y of t be equal to x1 of t convoluted with x2 of t. This is by definition integration minus infinity to plus infinity x1 of tau into x2 of t minus tau d tau. This I call equation 1. Next step as usual is to sketch what is x1 of tau and x2 of t minus tau. x1 of tau is same as x1 of t with the difference tau being replaced by t. T being replaced by tau, t being replaced by tau. So this is made now, x-axis is made tau, y-axis is x1 of tau. That means we have sketched x1 of tau. Next step is to sketch x2 of t minus tau. We know that x2 of t is equal to 1 for t varying from 0 to 1, 0 otherwise. This implies x2 of t minus tau equals 1 for t minus tau between 0 and 1, or minus t less than minus tau less than 1 minus t. Multiply throughout with minus 1. You get t greater than tau greater than t minus 1, or tau lies between t minus 1 and t, like we did in the previous problem. 0 otherwise. That means x2 of t minus 2 is a rectangular pulse of amplitude equal to 1 that starts at t minus 1 and ends at t. I am going to sketch now x2 of t minus tau. It's a rectangular pulse of unit amplitude, starts at t minus 1 and ends at t. The y-axis is written implicitly as x2 of t minus tau. This figure has to be slided against this figure to create overlap. Case 1. For t less than 0, for example t minus 1, these two figures do not overlap. For t less than 0, we find that x1 of tau and x2 of t minus tau do not overlap. When they do not overlap, this product will be 0, hence y of t will be 0. Hence y of t equals 0. This I will note down somewhere, y of t is 0. Just note down here, y of t equals 0 for t less than 0. Next case, first put the figure. X-axis is tau. First I will write this figure. This is 1, 2, amplitudes 1 and 2. This is the sketch of x1 of tau. x1 of tau is head stationary. x2 of t minus tau now we push to create the overlap. x2 of t minus tau will show always dotted. It starts at t minus 1, ends at t. This is the sketch of x2 of t minus tau. This is the overlap. This is the overlap. For t minus 1 less than 0, t minus 1 less than 0 and t greater than 0 or t greater than 0 less than 1, equation 1 gives, please watch, y of t equals limits of integration 0 to t. In the overlapping region, what is x1 of tau? It is 1. What is x2 of t minus tau? That is 1. If you integrate this and put limits, you get t. So I will write down here t for t between 0 and 1. We will go to third case now. We will go to third case. X-axis is tau. Zero, 1, 2, amplitudes 1 and 2. This thick figure refers to x1 of tau. Now this figure, I'll push it against this figure. So this could be the scenario. What is this edge? This edge is at t minus 1. This edge is at t. Now where is the overlap? Overlap is between t minus 1 and t. This is the overlap. I am going to say now case 3 for t minus 1 less than 0 and t minus 1 less than 0 or sorry t minus 1 greater than 0 because t minus 1 is greater than 0 or t minus 1 greater than 0 and t less than 2 or this tantamounts to t greater than 1, correct, t greater than 1 less than 2, we get from equation 1 what we get, y of t equals, now be careful, overlap is from t minus 1 to t. So I'll split the integral t minus 1 to 1. Please watch. T minus 1 to 1. What is x1 of tau? Value is 1. What is x2 of t minus tau? That is also 1. Plus integration from 1 to t. T minus 1 to t. Please note that x1 of tau has got different values. T minus 1 to 1. x1 of tau is 1. From 1 to t. x1 of tau is 2. x1 of tau, the dotted figure refers to x2 of t minus tau. From 1 to t, x1 of tau is 2, x2 of t minus tau is 1 d tau. I repeat, limits of integration should be from t minus 1 to t, but unfortunately x1 of tau has two values in that range. T minus 1 to 1, x1 of tau is 1. From 1 to t, x1 of tau is 2. However, x2 of t minus tau is 1 from t minus 1 to t. Now this has to be integrated. So if you integrate 1, you get tau between t minus 1 and 1. This if you integrate, you get 2 tau between 1 and t. So put the limits. If you put the limits, 1 minus of t minus 1 plus 2 into t minus 1. So what is the result? So this is 1, this becomes minus t, 2t, it becomes t. I'll write the answer over here. T for t between 1 and 2. The upper limit here is 1, that is the lower limit for the next case. For the next case that I am going to find, what should be the lower limit? It has to be 2. In this problem, integration limit cannot be from t minus 1 to t straight away. It has to be split from t minus 1 to 1, then from 1 to t, because x1 of 2 is having two values in that range. Next, case number 4. This thick line figure is x1 of tau. This amplitude is 1, this amplitude is 2, 0, this is 1, 2. Now this is the dotted figure which represents x2 of t minus tau. This edge is at t minus 1, this edge is at t. This is the sketch of x2 of t minus tau. Amplitude is 1. Now overlap is from t minus 1 to 2. I am going to say now, for t minus 1 less than 2, say t minus 1 is less than 2 and t greater than 2, or t more than 2 less than 3, equation 1 gives what y of t equals limits of integration t minus 1 to 2. What is the value of x1 of tau? It is 2. What is the value of x2 of t minus tau? It is 1. Integrate this. You get 2 tau when the limits t minus 1 to 2. Put limits, you get 2 minus of t minus 1. That is nothing but 2 into 2 minus t plus 1. So you get 2 minus t. So you get 2 into 3 minus t. So I am going to say now, I'll write over here. It is 2 into 3 minus t for t lying between 2 and 3. Last situation. If you push this rectangular pulse further, I'll show now. This is the sketch of x1 of tau. It starts at 0, ends at 2. This amplitude is 1, this amplitude is 2. The dotted figure refers to x2 of t minus tau. This edge is at t minus 1, this edge is at t. Now t minus 1 is more than 2. There is no overlap in the two figures. I am going to say now, case number 5, for t minus 1 greater than 2 or t greater than 3, x1 of tau and x2 of t minus tau do not overlap. Do not overlap. Hence, y of t equals 0. So I'll summarize now. Y of t equals, I'll summarize. Y of t is 0 for t less than 0, t for t between 0 and 1, t for t between 1 and 2, 2 into 3 minus t for t between 2 and 3, 0 for t more than 3. Now you see, what is the upper limit here? 1, that is the lower limit here. What is the upper limit here? 2, that is the lower limit for the next case. 3 is the upper limit here, which is the lower limit for the next case. So to check the correctness, we can see, from here we see, what is y of 0? 0. In this expression, put t equal to 0, what is y of 0? 0. You put t equal to 1, what is y of 1? y of 1 is 1. In this expression, put t equal to 1. What you get? Y of 1 equal to 1. You put t equal to 2. What is y of 2? Y of 2 is 2. In this expression, put t equal to 2. What is y of 2? Y of 2 is 2. Then you put t equal to 3. You get y of 3 equal to 0. In this expression, put t equal to 3. You get y of 3 equal to 0. Say y of m is 1 here. Y of 2 in both the expressions. Y of 3 0 over here. That says that the solution is okay. This is the end of module number 2.